with something a little bit more interesting on GeoGebra. Last time we modeled exponential growth. This time I'm going to model exponential decay. I'm going to go into those settings and change my zoom to start with and set up a few things. So my x-axis, I want this to be time. That lets me. It is, I'm going to call it weeks. Lovely. And this case here, I'm gonna want the y-axis to be my population, and that can be times 1,000 in this case. For my zoom, I'm going to start my population up around about 5,000. So I'm going to set this up at 6,000, just so I can see the very top of that. I'll need to go just so I can see the y-axis because I can't quite see it at the moment. I'm going to drop that down 1,000. For my x, let's go -5, and we're going to do this weekly. So a full year is 52. So if I go 55, I'll be able to set a full week. And I'm pretty happy with how that is looking so far. I'm just going to get rid of the grid lines to make it a little bit clearer from me. There's my two labels, which you can just see there. Okay, so now I'm going to plot my functions. I'm going to plot one with y starting at 5,000. And from there, I'm going to decay it by 10%. So that means it's going to get 90% of its value every time we record that, every week in this case. And there is my path. Let's put those into a table of values as well. Start with 0. I'm going to go just every 5 up to 55 every 5 weeks. And we'll put a mark on there just to see how that function is traveling. Now I'm going to change things up a little bit. This time I want to make another function. Let's just call this settings here. Let's give it a caption and call this decay 10%. And then I want it to show the caption, and you can see it now says decay 10% on there. I'm going to plot another function. This one is going to be, well, what I want to do is I actually want the decay to change at a certain point. So at this point here, which is 10 weeks into this modeled scenario, the population is now down to 1,743. So I'm going to go y equals 1,743. Let's write that properly. And I want the decay to reduce. I want it to halve. So only 5% decay looks like this. And then I'm just going to throw the power x to start with. Because I want to move across to the right there, I'm going to go -10, and that will shift, translate this across to the right by 10 weeks. Now I don't want it to show all those weeks before that, so I'm going to start at 10 and say that x is greater than 10. I guess that's less than 55 as well. Let's see if we'll plot that. Let's go duplicate input, and it's now drawn that in there. And I can add that to my table of values. And maybe I don't want to show that line in the same color, so we'll change that up. And I can give it a different label. So let's call this decay 5%. So decay 5% for that section. Fantastic. If we really wanted to, we could do a comparison of the two. Let's see how that goes. G of x, which is that blue function. Let's take away function f. Let's see how that goes. And if I put that in my table of values, it will then give me the difference between the two. I probably don't want to see that on the graph. So I might just go back here into settings, and let's not And there is a graph with two different values. I could always remove these ones if I didn't want to see those ones, but that's what I'm doing for now. And if I wanted to, once again, up here, I can export image, and there's my graph. If I want it like that, I'll be like, oh, there's too much down here I don't want. So let's just adjust a little bit more. Maybe I'll zoom in a little bit, or I can go back into my settings up here and tweak that as much as I need to. That's looking good to me. There it is.